what I want to do is I just want to go through how it works, right? How it functions. And later on, you guys can enter the information exactly. Um, so basically, one of the things you're gonna, and this is why we're doing these schematics, is this is an electrical schematic. It shows you how the circuit functions electrically. It's not necessarily how the circuit functions um, and how it's wired. So you have to kind of interpret in between both. So, and I'll explain that a little bit. So if you don't know this, this is C1, which is your power connector. So on the tray, you're going to have a connector which has C1 and it has pin A. And pin A is your positive. So I'm going to put positive here. So if your power comes in and basically change color here. So everything in the yellow is already there. It's already wired. You're going to check that to make sure it's wired properly. And you're going to give me the numbers where it goes later on. So this is already existing inside your tray. So you're just going to confirm that that wires are there to the switches and the connectors so that it works properly. So if I follow this and see if I can, so what you're going to do is you're going to label these. So it's a terminal block. So it's TB. I'm going to guess here, this is 3. And it's pin 4. So this is already existing. You're going to figure that out and write it in. And you're going to build basically this side of the schematic and you're going to hook up this side. So it may look a little confusing at the moment. So what I'm going to do is I'm going to this is C2, which is a connector. And we're going to go out. Out of C2, pin 4. And see if I can kind of quickly draw this for you. C1 is here. C2 is over here. And then C3. You have your lights and switches on the outside of your tray on this side. This is TB1. So this wire is already in there. So it's connected to there. So this wire you're going to have to add. And you're going to build a 4x4x4 harness on D subs. So 4 inches, 4 inches, 4 inches. It's kind of just like a jumper cable, or patch cable, just to make it fun and interesting. So we're going to go from TB3, pin 4. We're going to go across to C2. So there's 1, there, over to C2, and then this is my jumper cable. So I'm going to go out the jumper cable, back around, back inside the box. So now I'm sitting back at C2. So from, C3. So from C3, I'm going to put power to several spots. So this is one spot. This is the next. So basically I'm feeding 1, 2, 3 different spots with power. This is my TB1, and this is pin 1. So that's right here. So I have a D sub and I have a terminal block. And this terminal block has screws. Can I get more than one wire into a D sub connector pin? We've all crimped D sub pins. Can I get more than one wire? Even if I'm working 22 gauge wire, I don't think I'm going to get more than one wire into those small D sub pins, right? I've seen people struggling to get 2 in the splice last week. So the idea of splicing 2 wires together at my D sub is not going to work. So I have to figure out where I can put more than one wire. So again, this doesn't represent where the wires are. It just tells me that there's this wire is feeding 3 different spots. So terminal block 1 has a screw or a lug. Can I get more than one wire into a ring terminal? Yes, right, we figured that out already. We can determine the size or the color we need, red or blue, and we can get more than one wire. So guess what? Terminal block 1, pin 1 is going to be my junction point where I'm going to have all these wires coming in. So if I wanted to try and draw it a little more correct, what I would do is there we go. So I'm going to have a wire that comes from pin 4 over to terminal block 1. Then from terminal block 1, I'm going to have a second wire that's going to go over here. Then I'm going to have another wire from terminal block 1, and I'm going to bring it over to there. So terminal block 1 is my junction point. I can put up to 4 lugs, or I can put multiple wires, but you'll find out there's issues with that as well, but you're going to be able to solve that problem. So now I have my wire connected over here. So this is C3, C3, and C2, C2. I believe this is 8 and 8. And I think this one is 12. So again, this is my jumper cable. So what I've done is I bring my power over here to my terminal block. Then I'm going to go back out, around, and back over here, out, around, and back over here. So I'm now supplying power back inside the box from C2. So what I'm going to do is I'm going to have to put a wire from C2 to the light 1. And I'm going to put power from C2 pin 8 to light number 2. I'm also going to add a jumper here. It's going to power switch number 4. Switch 1 should be normally open, and this should be normally closed. So as long as I have power to light, it should turn on if I provide it with a ground. So I'm going to switch to green to show you the, so now what I want to do is I want to provide a path from the light to the relay. So it goes through the relay, and if I wired it correctly, so as soon as I turn or put power to the tray, light 1 should come on. Now I'm going to add some more detail. So this is your ground stud. Ground stud. Ground stud. And ground stud. So off of C1, the connector, you're going to have your negative, which is going to go to the ground stud. So it provides me with a ground. So if the light is connected properly, it goes to the relay, and the relay is connected to ground. So now what I want to do is when I push S1, when I connect S1, what is it going to do?
Energize the relay.
So it's going to energize the relay. So it applies power to the relay. And when the relay is energized, what are the levers going to do? So when I energize this, so when I push S1 down, it applies power to the X1, X2. It energizes, and my switch contact moves all down, right? It's all connected. This line means that they're all connected. So as soon as that switch is down, is there anything connected to this pole of the switch? Right, nothing connected. So that means that this now is, light 2 is turned off. But, or sorry, light 1, but light 2 still has power. And now it has a ground. So now light 2 has come on. So that's good. Switch 4 is a normally closed switch. So it has power sitting here. And it applies power. And the power comes along to here. And now I have supplied power to the relay without switch 1 closed. So when I let go of switch 1, the power is being applied from switch 4. So the relay is going to stay in the down position. So now I have what we refer to as I've latched the circuit. So light 2 is staying on even though I'm not touching anything. It switched from light 1 to light 2. How do I get it to switch back to light number 1 being on?
Push S4.
So if I push S4, what's going to happen is it's going to remove the power for the relay. And when I remove the power, it's going to remove, or it's going to let the relay go relaxed and back to what it was. And then light 1 will come back on, light 2 will go off. So again, start the sequence, push S1. With S1 closed, it will energize the relay. The relay will make contact and it will hold itself on until till an action causes it to reset. So there's nothing holding it on except the latching circuit. Does everyone see that? May look a little confusing. No, it's all good. So I'm going to clear that. So we're going to look. So basically, that is all inside the tray. So technically I need to add this wire, this one, and this one. So I'm gonna so this here and right. So this is my D-sub patch cable that I'm going to build. So that's already constructed. That's the 4x4x4. So this is going to be constructed. So I don't have to worry about that to wire. So I'm going to need this wire, that wire. I'll need a wire from the light to the relay, to there, to there. I'll need a ground, 1, 2, 3, 4. So, and then I'll need that one and that one. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, 15, so 16 wires of various lengths. Some of them are going to be really tiny, other ones are going to be a little bit longer. So not that difficult to add 16 wires to it to make it function. So the biggest part is to try and figure out when you do your tray ring out is to make sure you label the connections to your lights, your switches, and then your C1 connector. So you know where they are, where they're located, so you can wire to them. The dotted line represents what's inside the relay. So inside the dotted line is all included in that relay in the center. And you have basically junction boxes to hook up to. So I believe this is pin 13 and this one is 14. So the X controls is pin 13 and 14. So you got a wire from 14 to ground. Pin 13 goes over to your switch. And then you can ring out these. You can look at the diagram or the spec sheet for it to find out where these pins are. Again, one is common and one switches. So this is normally closed. So you should know the pin for the normally closed and you should know the common. And if you physically look at the bottom of it, if you pull it out of the socket, flip it over and look at it, you should start to notice some interesting things about especially these pins. And the X1 and the X2 are separated. And then these pins over here, again, there's physical details you can see when you look at it. So take your time, make your measurements, and then we're going to hook it up to make it work properly. Any questions? So yes, one of the things is you have your patch cable has 5 wires. We're only using 3 out of the 5. That's fine. There's 2 spare wires in it. Some of the connectors are slightly different, but all of them have usually an A and a B. Some have A, B, and C. Only the A and the B is used for the power. We're not using the other switch or the other 2 switches. You're going to have to measure them for the ring out, but the other 2 switches are not used. So there's only 4 things that we're using inside. The 2 lights and the switches. Again, hopefully it starts to make sense as you start to add information into your blocks where you're going to connect to, and then your cable and your grounds, and then again figuring out the relay. All right.